Okay, so let me tell you a little bit more about viruses. So all viruses require host machinery, and in that way, they can be viewed as parasites. They require the host cells to give them the machines that they need to fabricate new copies of themselves. In the absence of their host cells, they're completely incapable of generating new viruses. Okay, so all viruses encapsulate some genetic material. All right, and here's some examples of viruses over here. This is the class of viruses that affects bacteria. I'm going to be telling you quite a bit about those very shortly. But this is one example. These little lunar landers over here have legs that land on top of the cell. And then up here in this head, this head is stuffed solidly with DNA. And that DNA then encodes the virus genome. It basically has all the instructions that you need to make a new virus if and only if you have a cell around that can provide all the machines that are necessary to follow those instructions. Okay, so we classify viruses by what type of genetic material is encapsulated up in this head. So if it's either DNA genetic material or RNA genetic material, those are two broad ways of classifying viruses. And it turns out that's actually a pretty useful start. Okay, so viruses require this host machinery because in their life cycle, their goal is to make more of themselves. In fact, all viruses follow a very simple plan. They basically are looking for a new host to infect, and once they find that host, they will take over the host machinery and turn it into a zombie, a factory to produce themselves. Okay, so here's the simple plan that all viruses follow. They infect some host cell, synthesize new copies of themselves, and then release those copies to go off and find new host cells. And here's one example of this. This is the virus HIV. Here it is grabbing on to the unfortunate host, and then here it is infecting that host, making new copies of itself. Here's the DNA, or sorry, this is actually an RNA virus, and that's the RNA is reverse transcribed into DNA. That issue is not so important, but that DNA is eventually used as a template to make new copies of itself. And here are these new copies that are forming out here on the surface of the virus, and these new copies eventually spawn off to look for a new host to invade. And that's basically what viruses do. They will look for these unfortunate hosts to invade. Okay, now it turns out that the life cycles of some viruses are a bit more complicated. All right, this is the basic goal of infect, synthesize, and release. But it turns out some viruses go through a much more complicated life cycle. For example, West Nile virus, which appears in the news every so often, actually goes through a complex life cycle that includes multiple hosts. So for example, West Nile fever has a reservoir in birds. This is actually responsible for, every so often you find on your streets, for example, dead ravens or crows. That's because the West Nile virus has gotten in. That's one thing that could kill them is, for example, infection by West Nile virus. And then mosquitoes act as a vector to transmit West Nile virus between, say, horses and other mammals that are incidentally infected and humans. Okay, so this life cycle can be quite complex. It can include multiple hosts. Today, I want to introduce you to, I'll start with the bad viruses, and then we'll go on to the good viruses. So let me first start off by telling you that viruses deserve the bad reputation that they've received. Okay, and one example of this is HIV. Now, as a chemist, I'm in awe of HIV. HIV is an amazingly simple machine. It consists of, its complete parts list consists of nothing more than 15 proteins and some RNA, and that's it. This is amazing, right? A Boeing 747 has 6 million individual parts. HIV has 16 individual parts, and that's it. So this is an example of the viruses that you and I can name are going to be the ones that are really bad. Okay, so anything that anyone in here can name, that's going to be one of the bad ones. And HIV deserves that bad reputation. As my mother would say, HIV has no redeeming social value. And the reason for this is that it's responsible for causing considerable suffering and death on this planet. So in 2007, the year that I can get the most recent statistics, there were 33 million people who were living with the disease that HIV causes called AIDS, acquired immunodeficiency syndrome. And this disease caused some 2 million deaths in 2007. And I expect the number in 2008 to be more or less the same, maybe even slightly higher. Right? So this is a virus that is responsible for considerable suffering on this planet. And in fact, actually, if you look at HIV rates in places like Africa, the virus has changed the course of history. Okay? It's infected so many people that it's actually changed political history. And in fact, that's one of the characteristics of viruses.